So my talk today is about Spring, Amazon Web Services, and how we can wire that up to produce a backend for our mobile applications. So the kind of backend that we will be producing is a RESTful one. You have here the no XML icon. Some of you guys might be familiar with Spring, which means that you hate XML because a lot of people use Spring with XML configurations. It's absolutely possible to use Spring without using any XML, using only Java and Java annotations. And that's what we're going to do today when looking at Spring. So you might ask yourself, why is there a talk about backends at Mobile Warsaw, which is focused on mobile applications? Well, in the company where I work, we produce, in my team, mobile applications. But very soon, we came to the conclusion that it would be really cool to do this feature and that other feature, but we need changes on the back end. And being a large corporation, it's not so flexible. And you can't just turn around and get some Java developer to join your group. So we came to the conclusion that if we want to build better apps, we need to put our hands on the back end. And that's why backends are very relevant to mobile applications. You don't want your mobile application to look like a watered down version of the desktop version of the product the company is offering. Often, backend developers, they don't really understand what's the life cycle, or as we've seen earlier, the lull cycle of mobile applications, their limitations, how they communicate with the backend. It's not the same flow as desktop applications. There's lots of connection dying, retries that don't necessarily happen with desktops. So it's very important, if you want to build a really good mobile application, to have a backend that is built for it. So these are the takeaways that I would like you guys to bring home tonight after this talk. So first, I hope you guys will understand how backends work and their capacities, what different features involve in backend development, and I would really hope that you have enough knowledge, information, and examples to actually get started and try implementing something on your own for fun. And going back home tonight, you'll also have access to all the source code that you'll be seeing. So you don't need to memorize anything. All is available on GitHub, including the presentation, and the link is available at the end of the presentation. If you have questions throughout the presentation, please interrupt me, and I will answer your question. Okay. When we talk about servers, there is this question of how do we deal with the amount of users? Well, there are two strategies to doing that. You can either scale up, which is to add more capacity to a server. So you add more RAM, you improve the connectivity of it, you change the CPU, which takes time, or you scale out, which means that you add more instances, more machines that are equivalent in their functionality. And you want to scale to be able to respond to traffic. More customers, more traffic requirement, and you need to respond to that. If you use your own hardware, you can scale up reasonably well. It's hard, but it's reasonable. But you can't really scale down. If you don't have customers at midnight, you can't sell your hardware in the evening and buy it in the morning. That's something you can do if you're on the cloud. And that ability to modulate your offer according to your needs, it reduces your costs. you don't provide what you don't need. And if you initially purchase too much, you can just tone it down afterwards. So there are two cloud options that I'll be discussing today. Platform as a service, which basically is a provider will set up software for you on their hardware. And infrastructure as a service. So they lend you their hardware, and then you're on your own. You have to do your thing. So I'll be talking a lot about Amazon Web Services today, and I'm presenting a few of their products. So they both have platform as a service and infrastructure as a service. What I would like to draw your attention to here is the fourth row, best used when. So platform as a service, it's best to use it if it's not critical to your business logic. Do you guys know any product that has a really good database that's really performant? Probably not. That's not a dominant feature of any product. So that's a very good candidate for having the database tier as a service. As a developer, you're not going to add a lot of value if you're able to in a really good way, build rig replicas of your databases to fragment them. There's not much business value to it. So this is the kind of service that you would, the kind of offer you'd have as a service. Whereas infrastructure as a service, that's where you want to have your business logic. That's where you want to have what differentiates you. And that's where you have your backend server. Another important feature is the last row, disaster recovery. If you use Amazon Web Services, they have a lot of facilities to help you recover from disaster. A machine dies, it crashes fatally, there's a blackout, whatever. They have a lot of mechanisms to help you cope with such events. And when it comes to infrastructure as a service, it's much harder. You're on your own. You have to build your disaster recovery. So on your infrastructure as a service components, you want to be as stateless as possible, which is why you will build a stateless backend. And that's what we're going to be seeing. There are a few things, by the way, the presentation is 40 minutes, and I got really enthusiastic when I made the slides. So if you notice I'm not reading everything or mentioning everything, that's because I'll go over the most important points. You can read it at home and get more insights. So one thing I really like about cloud solutions is that it doesn't involve arcane DevOps. So you most likely are treating your DevOps almost as gods in your environment because they know how to deploy, and the things they do look so complicated and everyone needs them, but they're never available for you. If you use a cloud solution, the DevOps process is really, really easy. Easy enough for someone like me to understand it and be able to use it. Another point that's really interesting is here. You build your proof of concept on the cloud. And then, if your concept is good, you don't have to adapt a new version of it or modify the logic of it to be able to scale it up in production. Your development proof of concept environment can already be your development and production environment. There's no difference between those stages except for scale. And the last reason on the slide, which I believe is the most important, is do you as a developer or as a company want to invest time on hardware or software? I don't think any of us here wants to specialize on hardware. So that's a good reason. So a RESTful server works more or less like that. The phone sends a request to a front controller, which receives all the requests. Then it looks around and says, oh, you're looking for a particular resource? Let me see if I have a controller that can deal with it. It finds it, sends it the request. The controller deals with it, usually interacts with a data layer, computes a response, and sends it back to the phone. That's the quick version. So Spring Boot provides you a bunch of these things for free. It takes care of the servlet container configuration, for example, Tomcat. It does it all for you. Serialization and deserialization, it also does it for you. As long as you build your classes in a way that Jackson can serialize and deserialize. Now, if you're an Android developer, Jackson is something quite familiar to you. Spring Boot also takes care of your dependencies and their versions. It can be really frustrating when you're trying to use a bunch of libraries and you have to worry about which version of a library is compatible with another library. Spring Boot does it all for you. When you have a server, you usually have a web.xml file, which is arcane by XML definition. You don't have any of that with Spring Boot. Spring Boot also takes care of your server security. Not 100%, because as a developer, you can still introduce security issues in your application, but it takes care of a lot of things. And metrics for your server. So that comes pretty much out of the box. And then, with minimal efforts, you have access to a lot of these things. You can integrate with social networks like Facebook, LinkedIn, Twitter with relative ease. All the SQL data stores, a lot of the NoSQL data stores, you can integrate with them rather easily. OAuth 2, you can also implement it not easily, but not too painfully, because we're still talking about OAuth 2, so that involves a lot of pain. Message queues, and a lot of other features. So Spring is really powerful, and it will allow you to do a lot with relative ease. So using Spring, what you need to take care of is defining your controllers, their interactions with databases, and how to handle requests from your mobile devices. So, all right. So now, I will show you a demo of the code. I won't be doing any live coding, but I'll show you how it works, and then at home you can have a look at it as well. Here we have a Spring Boot application, and this is the main class that you have to fire to be able to run your server. So we will do just that. Okay, but before we do that, I will show you a few features of Amazon Web Services. So who's used Amazon Web Services before? Okay, a few people. What was your experience with it? Good? Who else? Okay, we're shy. Okay, so what I'm going to do now is I will set up a database instance that we can use afterwards for this application. So one interesting thing, about Spring and Hibernate is that you're not tied to the specific database you're using. You can switch around with with much ease. So here I'm setting up a free database instance, a MySQL one, and I will type in some information here. Almost. Okay, so I've just created a MySQL database server, and it will be available in a few minutes. As you've seen, it took less than a minute to start it up, and it's on the cloud, so it's relatively easy and fast to get around. This is the main, the home page of Amazon Web Services. It looks scary because it is scary. There's a huge amount of places where you can click. But the good thing is, you don't have to click everywhere. EC2 here, this is where you would set up your server. EC2 stands for Elastic Cloud Computing, and this is where your server will be. Next, we have Elastic Beanstalk. This is what you use to deploy your application. The most convenient way to deploy an application using Spring Boot and Amazon Web Services is to build a very, 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 very fat jar. You upload it to Amazon Web Services, and they run it and take care of it by themselves. It's really simple to build it that way. Next, we have S3. S3 is Simple Storage Service. It's like a huge hard drive in which you create buckets where you put data. For instance, user pictures. They have a profile, they have a picture, you store the picture there. If, let's say, you are a job board and you store CVs of your users, you put it on S3. You want to make backups of your database, you threw it on S3. So it's a really convenient storage service, and by being on its own service layer, your servers can use it, but if your servers die, the storage still persists. So that's a very interesting feature. Next, we have RDS, which is the Relational Database Service. It is what I use to create a MySQL database. So that's where you would have your SQL layer. We also have Dynamodb, which is a NoSQL document database. It's a bit more complicated, but it's there. You might want to look at it at some point. And you have here IAM, which allows you to create user accounts for your Amazon Web Services account and give specific permissions to the different components in your system. So you might want a particular microservice in your system to be able to store documents but not modify them. You might want your a particular microservice to store documents on S3 but not read or write on your database. So that's where you would set up that kind of permission. So we have already the MySQL database instance, and I actually need to, oh, it's still creating. Okay, so I'm starting up my application, and I want to show you now a very simple controller. This here has the REST controller annotation, which means that it is a, this class contains controllers. That's what it means. So we have here the mapping for this controller. So if you just type the address of the server /nothing, this is what's going to happen. Here we have another mapping with a parameter called name. So sometimes you would have a URL where you would see, for instance, on YouTube, watch video, and then slash a number, and then slash something else, something else. That number would be the name parameter here. So I now have the opportunity to show you another feature of AWS, which are security groups. Security groups are like firewalls. You can give access to your resources to specific IPs or components in your AWS cloud. So in the case here, we'll be providing access to my IP so I can connect to the database, which is what was causing that issue. And it's not very fast. Okay, give me a moment. Okay, so while my connection is figuring out to work properly. So the basic components of AWS, if you want to deploy there, you use Beanstalk. So Beanstalk is, you know that story where there's Jack, the kid who's poor, he gets a bean, plants it in the ground, then it becomes a huge vine? Well, that's the imagery behind Beanstalk. Jack in front of the castle. So you deploy to AWS by creating a .jar file that you then deploy to your machine on the cloud. So this represents the deployment process, where you can just, after you start your environment, upload a new version of it, and it gets installed on the different instances on your cloud. We've talked about S3. We've also talked about EC2, databases, IAM, and security groups. Another thing that is important in AWS is the load balancer. So this here is your load balancer. It receives all the requests directed to your server and then redirects them to the different servers that you own. A typical strategy for a load balancer would be round robin. I give you the first request, I give you the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, and so on. In Polish, I think it's called the algorytm kazurelowy. I'm sorry for that Polish. Another feature of AWS that's really interesting is that you can decide where you put your different system components. There are different regions. In Europe, there is Europe West, which is in Dublin, if I remember. And there's also Europe East, which is, or is it West too, in Frankfurt, in Germany. So depending on your client's needs, you can locate the server closer to them. And you can have different servers in different regions if you go worldwide. Within each region, you have different availability zones. So there are actually different data centers located in different locations. So if one data center goes offline for any reason, you can still have your servers and data layers replicated in other availability zones. So next, that brings us to persisting data. In Android, you use, I hope, I really hope for you guys, otherwise you hate your lives. An object relational mapper. So you don't have to write all that hateful boilerplate code for persisting data. An example in Android would be ORM Lite. Well, the backend world also has ORMs, and the most popular one is Hibernate. Hibernate is an ORM that is used in conjunction with GPA, the Java Persistency API. And it does all the heavy lifting, all the boilerplate code for you. So what you need to do is that you define one of your Java objects as an entity. You possibly give it a custom name. If you don't give it a custom name, it will pick a table name based on the class name. And you define the primary key using the ID annotation. Now you can do things that are much more complicated than that, but this is the basic. And in most cases, it's pretty much enough. So one of the really good things about Hibernate is that you don't ever have meetings about Hibernate. It's a non-issue. It works, and there's no question about it. It does have cons. If you use Hibernate, you're adding an abstraction layer, which might not be optimal for your business needs. So that's one thing to think about. But then again, you shouldn't optimize without measuring. And in most cases, Hibernate is going to do a pretty good job. So Hibernate has a language called HQL, which allows you to write SQL queries in a unified language. So whether you choose to use MySQL as a database language, or Microsoft SQL, or PostgreSQL, or whichever database, you can write your queries in HQL, and they will work regardless of the database provider you chose. So you're not tied to one database type. You can move around. Okay. So another thing that's really nice about developing backends for Android developers is that they can share components between their mobile application and their server application. And one of them that I really like to do is using retrofit as my client for network requests. So while I develop a backend server, I do integration tests to ensure that I'm doing something sensical. Developing those integration tests using retrofit, I already have all my networking done for my Android application. I just copy and paste it onto my Android application. So you just need to do it once, and it works just fine on both servers and Android. Now, if you tell people in the server world that you're using retrofit for your network calls, they'll think you're really weird because it's not a standard. But it works really well. It does the job really good. So you can save a lot of time doing that. Now, you have to secure your server in some way, in most cases, because you'll probably want user accounts. And if you have user accounts, you have authentication, and you have permission control. If I upload pictures of my baby girl, I don't want this guy to look at them. He looks like a nice guy, but I don't want to share my baby pictures with him, at least not yet. So I want to make sure that he doesn't have access to my baby pictures. And this logic of user accounts and permissions and restrictions is really straightforward with Spring. So inside your controller methods, you can inject a principal, which basically is what identifies a user. You use a username and password to authenticate, and then it's available in the controller for you to use. So you can use that information to verify if the resource that someone's trying to access is really owned by that person. You can also attribute new resources to that user. And you can do a lot of really interesting things that allow you to segregate access to your backend according to the rights that people should have. So I will show you one such example of using that injecting user credentials. So we have here on the screen, in the controller method that gets hit when the user makes a request, there is the authentication object that's used as an argument. This is going to be the user account of the person who's trying to gain access to that endpoint. Then afterwards in your code, you can do a lot of things with that user account. You can check if the user has the roles necessary to conduct this action. You can fetch all the objects that belong to that user. You can see, you can write objects that belong to that user. You can do very simple things like this. Get the username and verify if a certain user is trying to access some part of your code. So this is a very simple example of how you can do that. Any questions on this? Yes?
Is this authentication RESTful?
Sorry?
Is this authentication provided by Spring RESTful?
What do you mean by a RESTful authentication?
Can I use the login by sending credentials in JSON format?
That
And in the response not the response in HTML, but in the JSON.
Okay, so the question is, can I use JSON to authenticate my request? The answer is yes. In Spring Security, there are many ways that you can authenticate users. You can introduce an authentication flow that uses a JSON body element. It would not be the recommended approach, but you can still do it. There are many ways you can authenticate users. You can use OAuth2 tokens. You can use basic authentication. You can use LDAP. You can use tokens from other services like Facebook. There are really a lot of possibilities, and they're only limited by your imagination. Now, the flows that are easy to implement, they're not limited by your imagination. The easiest flows to authenticate with Spring is basic authentication. So with retrofit, basic authentication looks like this. You have a header with authorization as its key, and as a value you have, it's hard to see, it's so small. You have basic and then a base 64 encoding of your username and password.
So you're actually sending your username and passwords in every request, right?
And in this flow, yes. You can send your username and password once to obtain an OAuth2 token. That's another flow you can have.
What do you use in production?
What I personally would recommend is a basic authentication to obtain an OAuth2 token. Now that might not necessarily be the thing you want to do. you might want to have, for instance, in your application, a soft login, in which case you could use, for instance, a unique device identifier that you send as JSON body information to obtain a token. You could also send a Facebook token or a Twitter token to authenticate the user and then get a token from your own service. So there are different ways to authenticate a user, and Spring allows you to do that with relative ease. Now, I want to show you how that relative ease looks like. So here we have a setup for Spring Security where the users use a MySQL database. Well, rather, the server stores credentials in the MySQL database and consults the content of that database to verify the information sent to it. So that allows, for instance, to have a server layer that contains all the information required to create a session in a database that is independent from it. So if all your servers die for a reason, your database layer will still be intact, and you can start up new servers to restart your service. So that's something that can be achieved with just a few lines here. You set your database data to come from this particular thing that I will show you later, a data source, and you define the queries that you use to obtain that user information. And here we have the fragment of code that allows you to use basic authentication in your service, so HTTP basic. And you have here restrictions on certain parts of your application. So if you want to do GET requests or POST requests to any endpoint in your service, the user has to be authenticated. And here you have an account creation endpoint where you implement your own endpoint and your own logic that allows users to create an account. Obviously, when you create an account, you're not logged in an account. Otherwise, you would not be creating an account. So that's why you need to not be authenticated when you create an account. And that's what is represented there. So there was this magic object here, the data source. So the data source is something that you define. You tell the object in Spring, get my data from this database, use this driver, use this username and password to connect to the database, and it just does it. Here we have the properties, and you're looking at it, and it doesn't look like what I'm saying it is. One thing about the Spring framework is that it uses files called application.properties. This is where you can save properties for your system and store all of them at the same place. So we have here the driver that you use, username, password, the URL of your database on AWS, and your data source object connects to it. Here we have a very interesting line, a property called something very weird, but it's HBM2DDL. It's not representative of what it does. It actually does more than what it looks like. This will handle your database schema. Well, your objects, your tables. So if we look, for instance, at this object, mobvavers, because that's what you guys are, we have here the entity annotation. We have ID and generated value annotations. And that is good enough for Hibernate to, when you connect to your database, check if there is a table that has this name, if there is no table with that name, it creates one with all the fields. And if there's already a database with that name, it updates the fields so that it conforms to your Java object. So you don't actually have to write any SQL to create your tables. It all comes for free. Your question is, does this schema propagate to
every server?
It propagates to the databases.
Okay.
It comes from the server.
Many servers, yes. Does it propagate to everyone? To every server?
It doesn't propagate to servers. It comes from the server and propagates to the database. So let's say you have 2 servers, and then you add a third one. The third one, when it starts, it will look at the database and will try to update your schema. Now there's also an option where Hibernate doesn't try to do any of that. In a production environment, you'd use that setting where you don't update your schema just to make sure you don't mess up anything. But while you're in development, you don't have to worry about your database schema. It's all handled for you. Here we have a bunch of tools that I described that you can use. If you're interested, you can have a look at it. The way to build your application as a jar package is quite straightforward. You use the maven clean followed by maven package commands. It will create a fat jar that contains all your dependencies. Then you upload that fat jar to AWS. Then it takes care of itself to deploy your server application for you. Okay. So the last part here is where I compare AWS with Microsoft Azure and also the MBAAS, which are, I don't remember the B, but the M stands for mobile. So does anyone know what
Mobile backend as a service.
Exactly, mobile backend as a service. So on the left-hand side, we have project risks. Because we work with product owners, not all of us, but a bunch of us do, and sometimes the business requirements change along the way. Well, since you're on the cloud, you're not tied to any hardware decision that you've made, and you can turn around rather rapidly. If your team doesn't have the technical capacity to take care of the hardware, it's not a problem. The cloud providers will do it for you. If you're looking for someone who can take care of your backend or your cloud, Spring and AWS are standards. So it's rather easy to find someone who can take care of it. You won't be stuck with an obscure service that no one's heard of, like, let's say, Cold Fusion. Executives, they love Amazon Web Services. They're not quite sure what it means, what it stands for, but they know that you can build microservices on it, and microservices, they're cool. So that's one reason why they like it. And the last line there, the bad architectural choices. You might end up making them, but because you have the flexibility of the cloud, you can turn around and undo those bad choices rather easily. You're not tied to any hardware purchases you've made. And here we have a bunch of other characteristics, but I'm running out of time. So, how much time do you want to spend building your backend? Probably not a lot. We're mobile developers. We want to develop mobile applications. If we are to have a backend, which most likely we'll need, we might as well build it rapidly and without too much pain. If you are an entrepreneur and you start a new project, you need a backend. But once you're done building your backend, do you want to have an obscure solution that you will not be able to find someone to pick up? Or do you want to have a standard? And what's your budget? Do you have a lot of money to invest into hardware? Are you going to buy a bunch of hardware at the beginning of your project, have a huge cost, and then if your project drags on and is not yet launched, you're not getting any revenues, and that investment you made at the beginning of your project, it starts to wait. So, yeah. Do you guys have any questions? Comments? All right. Thank you very much.